The goal of this practice lab is load testing a RESTful API. The app we will create allows the user to get a list of software testing types or add a new one. A RESTful API is an application program interface that uses the HTTP verbs like get and post, and the goal is manipulating data based on a representational state transfer technology. So let's start by creating a new folder for this project, and let's create the Python virtual development environment using virtualenv. So if the environment is ready, now we can just activate it. Here, instead of using virtualenv, you can use Vagrant, Docker, or any other technology that allows you to escape the common dependency problems between your development environment and your host machine. We need also to install Flask in our environment using the pip package manager. That's why I was typing pip install Flask. So Flask is a Python micro framework, and we're going to use it in this practice lab. I need also to use the gitignore file, since we're going to use GitHub later. So I'm downloading a ready Python gitignore file from GitHub. Here I was using the wget tool, and I'm going to rename the downloaded file to .gitignore. Git uses the ignore file to determine which files and directories to ignore before you make a commit. This file should be committed into your repository in order to share the ignore rules with any other users that clone the same repository. So there is a collection of useful gitignore templates created by GitHub. The file I'm using was already downloaded from this repository, so you can visit it using the URL github.com/github/gitignore. Here we are creating the files and folders of our project. So we created a folder called app, and we are going to use a text editor or an IDE in order to create the app.py file inside of the app folder. So this is the code of our minimal API. In this code, I started by importing Flask, as well as the other libraries that I will be using. We have an initial dictionary, and it contains actually one test type, which is the unit testing. Our code has also two functions. The first one is called getTests, and it's used to get the list of tests from the testing types dictionary. The second one is called addTest, and it's used to add a new test type to the testing types dictionary. I'm going also to run a local development server by running the command python app.py. So as you can see here, I have a local server that started, and it's running on localhost on port 5000. Because I don't want to interrupt my local server, I will open a new terminal window where I'm going to test my API using curl. So the first request I'm going to test is the response of the API after a GET request. And as you can see here, I have the data that I added explicitly to the Python dictionary inside my code. So let's test another post request. I am going to use this command. Here I am adding a new data to my dictionary, and I am using the JSON format. This is why I should add this header called content type. The data is a new type of testing. Here I'm going to add it using -d, and it's followed by the JSON dictionary to add. The new testing type that I added here is load testing. As you can see, it has a name and a description. So once the JSON is added to my dict, I can test using a GET request. And in this case, I will get two types of tests. In other words, the test types that I added previously. So there is the unit testing and the load testing. This is the first part of our practice lab. We created an API that allows us to read and write software testing types. Now let's move to the second part. There are several types of testing in software engineering, and load testing is one of the most common tests. Load testing helps us determine the throughput required to support the anticipated peak production load and the adequacy of virtual and physical resources like load balancers and hardware. Load testing allows us to detect concurrency issues, functionality error under load, and identify how many users the application can handle before performance is compromised. Moreover, we can collect data for scalability and capacity planning purposes. Gatling, Gmera, Locust are some tools that could help us in this type of testings. In this practice lab, we are going to use Locust. It's a distributed load testing tool intended for figuring out how many concurrent users a system can handle. A swarm of locusts will attack our API. Also, the swarming process can be monitored from a web user interface in real time. Locust is event-based, so it's possible to support concurrent users from a single machine. Let's begin by installing Locust tool using the pip package manager. So here I'm going to reactivate the development virtual environment, then type pip install locust.io. Here are the installation logs. Pip is actually downloading Locust and its dependencies. It extracts the downloaded archives and runs the setup.py tool on these libraries. So my installation is complete. Let's go to locust.io website. There is an example provided in the home page that we can follow for our testing. So as you can see here in a Locust file, I should start by importing the Locust modules, then create a task set class, a website user class that will use the first class, and in this class I should create the different testing tasks. Here I have two tasks, one called index and the second one is called about. So if the website needs authentication, the instart method should contain the authentication instructions. Finally, the website user class should contain the task set to perform. So all of this should be included in the Locust testing file and executed using the locust.-f followed by the path of the file. So let's create the Locust file. And I'm going to add this code. So as you can see here, I have the imports, the task set class, and the website user class. Using Locust, I will execute two tasks. The first one will send a GET request, and the second one will store data in our dictionary using a POST request. The first class is describing the user behavior, and the second class, called website user, will use this behavior to start swarming locusts and stress the API once executed. So in order to perform this test, I am going to execute this command. So the command is locust followed by --host and the host URL, which is localhost, and I'll be using the port 5000, which is the port that our Python API is using. So you can see the execution logs here. Let's manually verify if our API is still running. So open your browser and just type the localhost followed by the ports and followed by tests. So alright, it's sending out the right data. Locust has a web user interface and it's accessible on the port 8089. So say our API should support a number of 10,000 users. We can start a test by giving this value to Locust using this web interface, as well as the hatch rate, which is the number of users spawned by second. So using this, the homepage of Locust, I will add the 10,000 as a number of users to simulate and 500 as the hatch rate. Then I should click on Start Swarming. Here we can see the live statistics about our tasks, like the type of requests, the number of fails, the median, average, min and max response time, the content size, as well as the number of requests per second. Using the charts view, we can determine some fact-based conclusions. For instance, if we don't accept a response time greater than 450 milliseconds, we know that our application should not handle more than 117 requests per second, and that the max number of simultaneous users should be less than 350. So this can help us in anticipating peak production load and determining how many users an API can handle before performance is compromised. We can actually map different metrics together to better understand how our application behaves. So don't forget that in this lab we are not using a real web server like IIS or Nginx, and that our performance and load testing results depends on the web server we are using. In this example, we are using a development server. So we also have access to other live statistics about the errors, for example, or the exception logs. And if you would like to visualize your data with other tools, you can download the testing data and import it from your preferred visualization tool. So in this practice lab, we created a RESTful API and tested its performance using Locust. Using the results from our tests, we determined how our API can behave with a certain number of users and requests. Load testing is an important practice since it prevents organizations from downtimes and failure. It gives meaningful results when tests are done in a similar environment to production. Thank you for following this practice lab.